Hello and welcome to another Java and I/O quick dive. Today we will have a quick look into Java and I/O completion handlers and attachments. We will be mainly focusing on attachment topic and we will discuss what they are and what they can be used for. So let's start by looking at asynchronous byte channel interface, which we interact with mainly working with asynchronous I/O. As my pretty sophisticated class diagram shows, this interface extends asynchronous channel interface, which itself extends from channel and closable interfaces. For the purpose of this video, let's consider two variants of read method on asynchronous byte channel. Here they are. Let's take a look at two variations of read method on this interface. There are other methods on this interface, but looking at these two variations of read delivers our point home for today. The first variant registers a callback object. This callback object is basically an implementation of completion handler interface. And the second variation is a method which just returns a future object that represents the read IO operation. So the method signature that you see in the picture is the first variation of the callback based read method. And that is the only method that which we are actually interested in, since this is the method that we can register a callback. So let's briefly go over the arguments. The first argument is a byte buffer that we call it the destination byte buffer, into which all the bytes from the underlying channel should be read into. But what is the story behind this generic type A? The second argument is expected to be of this very generic type. Moreover, as we look into the third argument, which is the completion handler that we are inspecting, the completion handler argument uses a contravariant syntax to introduce a generic type which has a lower bound on the very same generic type A. As you have already guessed it, A stands for attachment, and when you are using the callback API rather than the future-based API, an attachment basically allows you to maintain application state across completion handler invocations or your callback invocations. And just to refresh your memory, this is what is known as dispatching to completion handlers. So all in all, attachments are basically a collection of fields you would like to maintain and access within your IO callback code. Again, the callback code is just extending the completion handler. So an attachment can literally be any type. It is totally and absolutely in your control what you want to put in there. So in the next slides, we will take a look into ideas of type of fields that or type of information that we can keep inside attachment that makes sense. So we can start with the queue of byte buffers. You might want to consider maintaining a queue of byte buffers that you want to read or write, depending on your use case. For example, every time your read callback has finished, you might just want to enqueue the byte buffer carrying the pending data that the data has been carried over to that byte buffer after the read IO has completed. So basically you would put that byte buffer into a queue, and then you would want to immediately instantiate a new byte buffer and register another read callback with the new byte buffer that you just created, so that you can immediately get ready for the next read operation when the underlying channel is ready. So this way, all the data you read from the underlying network channel, for example, can be buffered into a non-blocking queue where they get processed for later async write operation. For example, imagine there's another thread that picks up or consumes from this non-blocking thread type queue, which basically pulls the byte buffer and then processes them and then registers a write callback. Additionally, attachments are a very good place or a good candidate to host a specific, socket specific or protocol specific atomic flags. We can consider atomic boolean, for example, for the very use case that this atomic boolean can tell us from the application protocol perspective if the underlying channel is in the read mode or a write mode. I would say this is pretty cool. So since this is an atomic boolean, this property can be inspected from different threads. Another very good practice is to also include a reference to the underlying asynchronous socket channel when dealing with such channels. For this specific property, I think we need to zoom back a little. Please consider again the relationship between a completion handler and an attachment. A completion handler is what we extend to implement our callback code. And a completion handler associates itself with a type of attachment. If you recall from the method signature on the callback based API of the read, we saw that there's a generic relationship between the generic parameter of the completion handler that you would pass into the last argument of that read method. So the completion handler associates itself with a type of an attachment, and it simply uses an attachment to maintain a state. So given that a completion handler can access the underlying asynchronous channel from the attachment, then within the callback, we should be able to examine if the channel is still open or valid. For example, we can consider running some cleanup operation if the channel is closed or is no longer valid to do I/O on it. Another general idea is to make protocol specific decision. For example, if we read certain byte message, should we use a different state machine implementation from our protocol perspective to parse the remainder of the byte stream or take other measures? For example, I don't know, signal clients to do certain type of actions. So this is just imaginary examples, but you get the idea that attachments basically can help you to maintain your protocol estate. All right, so let's recap. Basically, the idea of how completion handlers and attachments work together can be summarized in the following simple diagram. An attachment can help you maintain protocol or channel-specific state across callbacks, which extend the completion handlers. And that's it. This is Reza from YouTube channel Between the Machines, where we will talk about interesting topics on programming and tech. The channel is fairly new and I'm trying to add helpful content, so please consider subscribing for showing support. Thanks for watching, and hopefully I will be back with another video very soon. Thanks.